So yeah, please confirm you can see my introduction to DevOps slide.
Can see it. Can see it, sir.
Okay, so yeah. So building upon what we discussed last week, like I said, this week is just for the preliminaries. We'll talk about introduction to DevOps and everything that involves the underlying knowledge regarding DevOps. Yeah, so um yeah. So to continue from where we stopped last week, we talked about this is the pipeline overview. Now, in your DevOps journey, you will hear a lot about pipeline. Oh, pipeline. Being a DevOps, within a CI/CD pipeline. So a DevOps typically consists of a pipeline which moves your code from the um, local environment to the cloud environment. You get all to wherever you're deploying it. Um, yeah, so the pipeline overview starts with the source control. So that's what we are learning next week. We're learning source control. We are learning source control, which involves, code repository. So code repository is basically where you store your code. It's like a library. It's like your home, the home of the code. For people to view, can be either public or private. Public is for outsiders to view. And then private is for, within your company or within your set of friends or just set of people that you don't want the code base to be exposed. But in general, GitHub is like a code repository system where you store your code. Now, most people confuse Git and GitHub and GitLab. So let me throw down a distinct difference. Git is a version control system. And what version control is? Version control basically helps you to track your code changes, to roll back. For example, you wrote a particular code and okay, your engineering manager has probably requested for you to change some certain things in the code. With Git, you can easily manage those changes. You can roll back. For a situation where you probably wrote a new set of code on an existing code and the new set of code does not work, and you're requested to tune back to the old code. So, I say configuration, Git's version control also works in such scenarios as well. So the first part of your pipeline is source control. So your pipeline always starts from a source control. It always starts from either GitHub or GitLab. So GitLab is basically like another version of GitHub where you store code, and then there's Bitbucket. There's GitLab, GitHub, there's Bitbucket, and there are some other repositories in Azure and AWS cloud. But these are the ones that are primarily use GitHub and GitLab. So you source control. Now, from the source control, that is where you create a CI/CD, which is an continuous integration and deployment tools, which is the GitHub Action. So where you start from whatever source control you are working with, you use their native or third-party CI/CD tool, which is for GitHub, you use GitHub Actions. Now, GitHub Actions is what helps you to create that pipeline that you use to deploy the code to, your production environment. In GitLab, you also have GitLab CI. So GitLab CI is also GitLab's own native pipeline, environment where you can create, your deployment pipeline. Now, Jenkins, we're not really looking at Jenkins in this class. What we'll focus on, when we get to the CI/CD is mostly GitHub Actions because that's what is popular in the market. But for your own learning, you can pick up Jenkins. It has a bit of a learning curve, but it's also good to learn. Jenkins is a third-party CI/CD tool which integrates with every which integrates with other um source control code repositories like GitHub and GitLab and Bitbucket. Yeah, but you have to configure that one. You have to configure that one yourself using a host and all those ones. So like I said, those ones, that's a learning curve on its own. Then within the pipeline, you have the testing part. So the pipeline has to include automated testing, just like what I said. There are automated testing frameworks such as Selenium, JUnit, and SonarQube, depending on what you want to do. SonarQube is what I use the most because what SonarQube does is to help to identify code smells and some vulnerabilities within the code. For example, you may be coding, your developers may have written some certain code, but within the code, they didn't hide some API keys properly. They didn't cover it properly, and then they now go and deploy it to a code repository. Tools like SonarQube can pick up that mistake and flag it before your code goes into production so that developers can easily remove it. That's what automated testing. I think the last time we had a class, someone mentioned what is the job of a software tester and testing in DevOps. Like I answered, software testing basically tests the functionality of the code, test if this particular one is working, test the components and the rest. But testing in a DevOps pipeline basically involves vulnerability testing, involves security testing as per the other part of the code that hackers could easily exploit and enter into and gain access to the software. These are the tools that help to eliminate, identify and pick up those parts of the code that the developer should work on and close out so that there will not be vulnerabilities. And until you pass this SonarQube or this security checks for your code can be deployed. Now there's also artifact management. So when you have gone through the test and then your code is built into an artifact, you need to store this artifact in an artifact management repository. There are platforms like Nexus. So whenever you build, like now, for example, when you write code, for those that are not familiar with the whole build processes, when you write code, for you to use the code, you have to build it. For you to use the code, you have to build it. And this building involves compiling the entire code into a runtime, Then that runtime now, you have to store it somewhere, that is just kept and properly versioned. So the build artifacts, like tools like Nexus and Artifacts, will help you to properly store those artifacts. Then deployment also is part of the whole pipeline, which is containerization and orchestration with tools like Docker and Kubernetes. We will learn Docker in further class. Then monitoring. Monitoring is also an essential component of this whole setup because you must monitor your applications. Any system that is not properly monitored, you won't know when stuff goes down and you just keep struggling. You just keep struggling to find bugs and to find issues whenever it occurs. So this is how a full pipeline goes. So from your source control to monitoring makes up what they call the software development lifecycle. Throughout your career, you're hearing it, and this is what it entails, the software development lifecycle. So yeah, that's it. The next one, popular DevOps tools. So one thing you need to know as DevOps engineer is that you're not limited to a particular tool. Any company that you find yourself, you must conform to the quality of tools that they use. You must conform to the quality of tools that they use, and you have to learn it to get the job done. All of them still follow a fundamental concept, but they are just probably UI difference, but they still follow a fundamental setup. If you understand one, it will be easier to pick up the rest, as you go. That's how you will see DevOps engineers of like 5 to 10 years experience. They are vast with a lot of tools, not because they sat down and learned it, but because they have been integrated into environments where This company use this tool, so they have to learn on the job. You get, for example, myself, I'm an avid AWS user, but I've been pulled into projects where I've used tools like Google Cloud. I've used tools like Azure. I say tools. I've used cloud platforms like Azure. I've even done some on-prem setups. You cannot tell them you don't know it because you need to learn it. Now, there are popular DevOps tools. First of all, for version control, which is the beginning part of the pipeline, there is Git, like I mentioned. That Git comes with, GitHub for code repository management. There's GitLab and there's Bitbucket. These are the popular ones that you hear mostly. Then for CI/CD, you have Jenkins, you have GitHub Actions, you have GitLab CI/CD. You can be Googling all these things while I'm talking. You can probably screenshot and then you Google them and check them out. Then there's Argo CD. So Argo CD is for cloud native deployment. If you want to build applications that run on, if you want to create pipelines for applications that run on containerized environment like Kubernetes, that's where Argo CD shines in. Argo CD is very, very good in Kubernetes-based environments. But also I listed them here. Then there's configuration management, there's Ansible, there's Puppet, there's Chef, and there's SaltStack. The most popular one among these is Ansible, because Ansible is easier to integrate, unlike the rest that, there's a bit of a learning curve. So that's why we are going to learn it as part of our learning process. The next one is containerization and orchestration with tools like Docker, Kubernetes, OpenShift. So when you talk about containerizing software, we'll get into that. Yeah, these are the tools that are the most popular. The most popular are Docker and Kubernetes. Only some companies use only very few sets of companies use OpenShift, but OpenShift still has if you have fundamental knowledge of Kubernetes and Docker, you can still operate on OpenShift. Then monitoring, there is the Prometheus, Elk Stack, Grafana, and Splunk. Yeah, most people use Prometheus and Grafana. Now, Elk Stack simply means Elasticsearch, Logstash, and Kibana, which is for monitoring, logging, and tracing, which are the three observability. They call it the three rules of observability: metrics, logs, and tracing. We'll get into that, like I said. So when you want to come to monitoring your software, when I talk about monitoring basically means integrating certain components of your software with these systems to be able to, track whether, your software is running, how many users are currently running through the software, how many, what they call it, how many, how much traffic is going in, how much traffic is going out, if it's getting overloaded and all those stuff. These are the tools that you get to integrate. Then there is cloud and infrastructure as code, which is AWS, usual AWS, Azure, GCP, which is Google Cloud. Now, infrastructure as code, meaning your ability to write the code you used to write to work on this cloud environment, which is Terraform and CloudFormation. Now, the last but not the least, and popular DevOps is for security and compliance. You have HashiCorp Vault and HashiCorp Vault and then OSWAP Zap. So HashiCorp Vault is like a secret management system where you can easily use to store passwords. For example, now you're setting up stuff where a lot of secrets, you can easily store them in HashiCorp Vaults so that it will not be exposed and the rest. SonarQube, like I mentioned earlier, is for security scanning, which is also part of security and compliance, because you won't want a situation where hackers can easily see passwords spread around your code. So yeah, basically. The next on the list is tools used at this stage here. Yeah, so this is it. Plan. So this is the plan phase. Like I mentioned in the first class, the plan phase. So plan phase, Jira, Trello, and Confluence. So these are tools where, for example, when you work in a company, when you get into the company, your first task would be they'll give you what they call a Jira or a Trello ticket. Now, the Trello ticket to contain your task and the description of each task. For example, Dockerize the front end of the application, put it in a Docker container. It can be in a Jira, they can call it a Jira ticket because it's just like a flashcard of what they need you to do at that point. It comes with timing, 2 days. This can be finished, the deadline or due date 2 days from now. Or deadline 1 week from now. Hopefully, we're not going to give you 1 week. They'll give you like 5 days or 4 days. Trello, the same thing. So all these things are for tracking progress. If you have worked in a tech background, particularly not even in DevOps, you will see Jira tickets. You wake up in the morning, or by the end of the day, the manager will probably assign you a Jira ticket for the next day, and you get everything done. You get everything done. Confluence is the same thing. Confluence is mostly for documentation. What Confluence does is, now, unlike Jira and Trello, what Confluence does is mostly documentation as per. They'll give you like an overview. For example, now, what a ticket to tell you, oh, we need you to Dockerize the Apple application, and they give you 2 days. For Confluence gives you, Confluence, you can get like an overview, like a full explanation, like in a document of what you need to do and your deliverable. So these are all the tools that you need in the planning phase. So for example, now if you can be apart from being a DevOps engineer, you can also be a DevOps manager or a DevOps program manager, where you assign tasks to people, the DevOps tasks to people to execute, and give you feedback. Then there is the develop. There is the develop phase, which is Git, GitHub, GitLab, Bitbucket, like I mentioned. When you write your code, you store them there as code repositories after you've gotten your tasks from Jira and Trello. Then there's the build phase. So these build are what you use to build your applications, make it into a runtime, basically. And then make it into a runtime. And yeah, these are the tools. We won't really go into them, just to know them: Maven, Gradle, and Bazel. Then there's the tests, which is Selenium, JUnit, SonarQube. Release is like I can mention. I think I showed you like an infinity sign of these whole steps last class. So these are like an explanation of each tools you use in those phases. Then deploy, Docker, Kubernetes, and Terraform. Operate, which is operating the application. Ansible, Chef, and Puppet. Then monitor, Prometheus, Grafana, else. So this tool, if I would, you can take a screenshot and probably go and look through them, understand what they do, understand their underlying technology and the rest. And this class is going to be quite short because we're preparing. You just want to prepare your mind. It's not as if you just go and rush into Git or rush into the meat of the matter. You want to prepare your mind. Or these are the things that even if we don't learn them in this class, these are other options, because we cannot be learning 3 tools to do one particular task. For example, you want to do operations like configuration management, you learn Ansible, you learn Chef, you learn source stack. I want to know that in as much as we are choosing Ansible, we are giving you the reason why we choose Ansible, because of the market demand. But there are still other options, because you can be in a company where you'll be like, oh, we want to switch from Ansible to Chef. You will not go and resign because you cannot do Chef. You understand? You have to understand, okay, how will we move our infrastructure from Ansible to Chef? What is Chef? All that kind of stuff. So I'm giving you a broad range of everything you would need. For example, for this particular setup, what are the tools that are involved? We are learning Ansible in this class, but what are the other ones that can be used to do it? So that's what this whole setup is for. Just prepare your mind, because like I said, it's a mindset thing. It's a DevOps is basically problem solving. You have an application, you want to move it to use for users to get. So you have to understand. Yeah, so challenge is cultural resistance. Now, when DevOps is not really entirely an old concept. You get DevOps is not an entirely old concept. The concept of DevOps is not up to 20 years old, if I'm not mistaken. You can Google it. The whole concept of DevOps is not up to 20 years old. Bad as bad, like in the worst case scenario, 20 years old. Because these are concepts that just came out of the growing need and demand for software systems, the growing need to ship code faster, the growing need and demand for, like, as companies were moving their infrastructure to the internet, you know, unlike the 90s and early 20s where unlike the 90s and early 20s where um you can see like just one internet related company out of 99 or out of less than like out of 19. Everybody did their systems on paper and pen. Lawyers, doctors, everybody recorded on paper and pen. And sorry, sorry. So, like I was saying, everybody recorded on paper and pen. And so the internet was more like a facade, something that people just looked and passed, you get. But as time kept on growing, they realized that, oh, this internet is something that we can easily adopt to get our work done faster. So every field of endeavor, we're moving their systems to the internet, not just even to the cloud, but getting access to the internet. So there was need to ship software faster. There was need for people to adopt to working on the internet. That's where you will see things like before, things like remote work was not even a thing. It was just like something that people were doing in person. Because everything now is online. If you go to an average hospital, their records are online. If you go to an average law court, if you go to fact now, even libraries are online because of that constant need to reach the internet. That is what DevOps, helps to bring. Because DevOps helps, like I said, it helps to shift software faster so that that demand for information will constantly be met as information is changing. Once information change, you probably change the code base and you are pushing it. So every split second, software is being shipped. That is what brought about the concept because traditional IT did not really allow for those split second change. You have to go through probably management, you have to go through setting up, you have to go through, like I explained in the last class, you have to go through complex setups just to be able to ship the code. And then complex passage, just all those things. Sometimes code can be shipped in like 3 days and it's not a guarantee that code will work. So yeah, that's just it. So there was a cultural resistance initially, shifting from IT operations. But as time goes on, in as much as there are still, I won't deny the fact that in as much as we're in 2025, there are still some companies that are still resisting. So still resisting adopting DevOps as a culture, as a setup. But as we grow older, now that there is AI and the rest, we'll just see how it goes. And then there's tools complexity. Like I said in the last class, if you remember, DevOps is all about tools. You're going to learn. See all the things I listed that you're going to learn them. Apart from, yeah, all the things I learned them are mostly tools and you will learn them. If you're in scenarios where you use different tools for different setups, you also have to learn those tools. Security concerns. People always thought that, with DevOps, there are no proper security. You can just, write a pipeline and the rest. That's why we brought about embedding of security with SonarCube and the rest, where you can easily scan code and all those stuff. Then there's a skill gap as well. People don't really know this, DevOps is not something that people actually know. They just learn about it, but it's something that don't actually know about it. So that's the challenge. Legacy systems. Now, I think this is even the major problem because most of the systems that people use are old systems running old infrastructure. So the challenge of DevOps is the ability to move. Most people don't want to move to new administration because it is a bit challenging. You get based on the fact that what is already working, they don't need to fix it, basically. So those are the challenges, basically. Now, these are the benefits. Now, first one is reliability. I don't know if the is self-explanatory. Moving code is reliable. There is reduced time to recover. There is efficiency. That's the most important thing. Your code movement your deployment movement is efficient. There's lower risks. There's shorter dev cycle and there's more stability. So you don't have to think of back and forth, when something is wrong, you don't have to think of how you start going back to figure out what the problem is. Everything happens within the software development life cycle within a few minutes. Then there's faster updates, there's better user experience, there are fewer failures, there are higher quality, and there's faster product delivery and cost savings. So yeah, that's just it. They are all self-explanatory, as you can see them. Now, benefits of learning DevOps skills in 2025. Yes. So first things first, 24/7 infrastructure support. Now, when you work in a company, you you are responsible for the infrastructure of that company. So you are the one that will ensure that the code is stable, the code is well managed, the code does not have, you know, the code does not have bugs, the code is secure and basic things. So yeah, that's basically your work, 24/7 infrastructure support. There is deployment, configuration, and performance monitoring, which is your work. Incident analysis and resolution. That's great for learning DevOps skills. You can easily manage incidents, and resolve them in shorter time. You can easily create backups and recovery. With proper DevOps skills, you will know how to properly back up and create disaster recovery scenarios. Because there are situations where probably your database goes down and then you have to bring it back up in a split second, or you have to switch to another setup that's probably a disaster recovery setup. You know how to set it up. Then with learning DevOps skills, you will know proper account monitoring and cost optimization. So you know that setting up SUSO infrastructure will involve spending X amount of money, Y amount of money, because your job is also, in as much as you're trying to deploy applications and set up systems, your job is also to save costs. So everything you are doing in a company must be to the cost optimization of the company. So you have to learn how to get it done. Next one is cloud native DevOps automation. Everything you are doing within the company, like I said, you have to learn how to automate. No manual processes, because why? A DevOps engineer. Yeah, so that's being said. So next, visualization tools for this. Now, this is the one where we're going to do for this course, like I mentioned. Version control with the Git and GitHub. Essential tools for source management and configuration. CI/CD tools, GitHub Actions, automated workflow testing and deployment. Configuration management, we're talking about Ansible. Containerization and orchestration, we're talking of Docker and Docker Compose. These are the two that we're going to work with. In cloud platforms, AWS. So these are the stepping stones to get you started in this whole setup. These are the stepping stones. We have talked about the extras, but this is our pinpoint for this training. This is our pinpoint. We're not going to do more than this. These are the tools we're going to use. Yeah, so thank you. Thank you very much for signing up. Thank you very much for trusting me to take you on this journey. It's not going to be easy, and I know I won't deny the fact that I won't come and sugarcoat anything for anybody that it's going to be an easy one. It's not going to be an easy one. Like I know the number of people that were in this class last week, and I'm already seeing the number and dropped because of probably fear or something. But at the end, to be honest, they're all going to be worth it because it's a skill that you're going to learn, and it's a highly paid skill. So it's something that we should buckle up. We should buckle up, put our seatbelts on, and enjoy the ride because it's going to be really, really fun. Yeah, like I said, it's a beginner's class, so I don't expect you to do any complex setup, anything. It's something that will get you off. It's something that will get you off the off the bandwagon, get you started. Just give you that throttle that you need. So yeah, that's that's what it is, basically. So, any questions? Okay, let me stop my screen share so that I'll see your screen. Elijah and Victor. This is Victor from last class. Congrats, come. Welcome. Victor,
Good evening, sir.
good evening.
Okay, I just want to confirm something. He has
Okay.
stated that most of the tools in their categories, they have
Mm-hmm.
they may not have the same user interface, but they may have the same systematic functionality. Like
Yes.
let me say in the category of Ansible, Terraform, and Kubernetes.
Mm-hmm.
While we are going to treat Ansible, so it's still possible that when you gain the knowledge on Ansible, you can
Mm-hmm.
easily navigate Terraform and Kubernetes. Is
No,
that correct?
Ansible and Terraform, they're different things, so
I know, but they are in the same
okay.
category.
No, Ansible is configuration management. Terraform is
Okay,
infrastructure
Chef
as
and
code.
Puppet. Yes, okay,
Yes,
okay,
yes, Chef
okay,
and Puppet. So if you learn
okay.
Ansible, I won't say you won't have to, you have to still learn the usability of Chef and Puppet, but the underlying results is still the same. What they are doing is configuration
Yeah,
management. So if you understand the concept of configuration management with Ansible, see, we're not going to only teach tools, we're also going to teach concepts so you can switch. Like I said, for example, I've been an AWS person for a longest of time, but recently I started diving into Azure and I started diving into Azure and GCP because I already understand the inner workings of AWS environment, so I could easily switch. It's not just coming to learn tools. Oh, I want to learn Ansible. No, we're learning configuration
Google.
management. We're learning configuration management using Ansible. So that when you're in a situation where you have to use Chef, you just have to learn, oh, what am I going to press? What am I going to navigate? Because you already know the underlying concept of configuration management. You
Yeah,
get?
yes, sir.
So that's just it. So the next
Okay.
person, Elijah.
All right, thank you, sir.
Thank you.
Bonus, can we connect with you on LinkedIn?
Sure, no problem.
Okay, thank you.
Thank you. So, next person I called, I think is okay.
Good evening. Good evening,
Good
sir.
evening. Good evening.
Okay, sorry. You talked about this class being a beginner class. So
Yeah.
I wanted to ask, after this particular cohort, is it that we will need to maybe go for the intermediate class before you can
Uh,
boldly call yourself a DevOps
no,
engineer?
you don't really need to. You can always upskill now. It's a matter of building projects. Classes are just to get you on
Okay.
the classes are just to get you on the road. You get classes are just to get you on the road. You have to use what your underlying and
Okay.
what makes you stronger basically is building projects. at meeting complex projects and handling them. That's what makes you strong as a DevOps engineer. So it's not just enough to learn. What I'm trying to say that this is like a kickstart. You get, this is like entering the road, basically. When you enter a road and you're driving, it is not what you learn. It is not what you learned in the beginning of the road that you use to solve, situations when you're on the highway or when you are counter trailer or something. This is, the more you build projects, basically, the more you get stuff done. There are a lot of projects online. There are a lot of code bases. There are a lot of like free code online that you can easily just use to kickstart and just generally improve yourself, basically. So yeah, you need to also learn the intermediate, but it's not like a compulsory something that you must learn the intermediate before you can do. Everything we're going to teach you here is enough to get you started, to help you build projects and reduce up. And that thing also as well. And that thing also as well is what they call it, building in public. You get, when you build stuff, put it online, let people see. Tech is not something for tech is not something you say you're a shy person. No, you have to learn how to put yourself out there. Create a name for yourself online as a DevOps engineer. That's how you get access to opportunities, basically. The jobs I've gotten as a DevOps engineer is not jobs that I've applied for. It's jobs from people that know you, because it's your inner network that will always recommend you to outsiders. That's just it, basically. So do you get what I said?
Okay, thank you, sir.
Okay, so Otuji Alphonsus, good evening.
Good evening, sir. Good evening,
Yeah,
everyone.
Good evening.
Thank you so much, sir.
Yeah.
Sir, please, I want to know if there are places you can refer us to for materials, sir. Like where we can actually go to like make some inquiries and research to help ourselves grow while you still take the class, sir.
Number one, there's Google, first of all. There's Google. You can always Google. There's some guys on YouTube that you can learn from. Apart from KodeCamp, obviously. KodeCamp is also, like I said, we're going to teach you to a good amount. But if you need some extra knowledge, probably from another source, there are some Indian guys on YouTube which you can use it to basically learn how to build projects. But I would advise you to finish this training first, because you cannot just go and jump into a project when you don't know the underlying concept. So this is what will teach you like the underlying concept that you can now use to, you can go and see, how to build, for example, now you can build, how to Dockerize a PHP application and deploy to AWS, how to write a CI/CD pipeline for a Node.js application, all those things. You will learn the underlying concepts here, and then you can use some of these Indian guys on YouTube. I can't really think of one now, but I will probably share on the group that they are good at all these project-based scenarios and the rest. You can easily use it to build your knowledge. But I would advise you to, in as much as most people drown in the hell of tutorial, what they call it, tutorial hell, where they just, if they want to build a project, they watch video on how to build it. No. The best thing to do is take on a project. I need to deploy this application. Figure out a way to deploy it without any video and deploy it. Write the code, fail. Your code will definitely not work. If your code works once, you did not write it well. That's the simple truth about DevOps. Have it from me. If your code works once, you did not write it well. There are two things. Either you copy from somewhere or you used AI, which is not advisable. AI is only for help, but it's not something that you should use to know without underlying knowledge. So if you don't know the code, you won't be able to succeed. So get software. There are open source software that I can easily get build up on it, learn it, fail. You can see your pipeline itself can fail like 20 times before you get the one time that will deploy the application. That is a learning process. I've gotten to situations where pipeline will fail like 30 something times, X, before one final green. That's what makes you a DevOps engineer, because those 30 something scenarios is what will help you to build the experience as a DevOps engineer. To build the experience as a DevOps engineer, basically. So yeah. Any more question?
Okay,
Did I
sir.
answer you?
Thank you. Yes, sir. Yes, you did,
All
sir.
right.
You answered the question. Thank you so
No
much, sir.
problem. Okoyo, good evening.
Oh,
Let me answer this, Okoyo, if I go back to you, Victor.
Yeah, hello, Mr. Ezekiel Messi.
Good
Good evening.
evening.
Yeah, good evening.
Yeah.
Just like the last speaker said, the last person that asked the question, some of us are not even tech savvy. I thought the first time you said Ansible, I thought you were saying Anselm or
Okay.
something, you know.
Yeah.
It's looking like you're speaking French. So for those of
I
some of us
understand.
that don't know anything, like trying to learn how to talk literally in tech,
DevOps. Yeah.
not even in DevOps. DevOps is big English. In tech, what are the pointers? What is like the stepping stone? If
Okay.
you
I've
remember the
read.
last class, I
Okay.
asked that the curriculum you gave, there was nothing to read up on or
Okay.
trying to, because I tried to go through so many things online. It's just basically story, and I don't.
Okay.
So it
But
was a bit scary and challenging.
yeah.
So
I will take out time to add some resources, probably this weekend, to add some resources that you can read up on. But I understand where you're coming from. You get, I understand. Basically, you have more work to do. You get to learn, to actually get, I outlined all the resources we will use. You can go on Google, read them out, read what they do. The whole concept of this course, we're not teaching tools, like I said. We're teaching you the concept. So during the class, you understand the concept even before using the tool. That's why I said when you understand the concept, no matter the tool they bring to you, you can easily find your way around because you understand the underlying concept. So that's what we're going to teach. So you may be afraid that, oh, probably you're not familiar with tech and all those things. It's fine, it's definitely fine. But by the time we teach you the concept itself for every single phase, you would understand it, and then that's where you will now build upon. Like I said, this is the most foundational class you can see. It is ground zero, basically. So, in as much as here we're talking previous talk, but it is the most foundational class you can get, because we assume that, okay, you don't have any knowledge at all, and we build upon that. If you have any question, I'll add some resources to the curriculum for more reference and the rest. Try this weekend, and then you can go through it and we'll start the class. That's why the class is, like I said, ground zero. We're learning everything tabula rasa for those that did philosophy, blank slate. So yeah, that's just it. So don't be afraid for, oh, I may not know tech and the rest. You will get to understand it. So for this course, like I said, we're not learning tools. The tools will probably make you afraid, but when we get to learn the concept, you understand the concept, be like, oh, okay. So now you now learn how we use these tools to achieve this concept. So that's just it.
all right, thank you for the confidence. Yeah, thank you.
Thank you. So Victor,
yeah, okay. Good evening once more.
good evening.
About what you said, you said if we write a code and it fails once and it works the first time, it means that the code is not correct.
Yeah.
Okay. I want to ask, is coding a base how do they say, like somebody that wants to learn DevOps, must you know how to code? And is it also a
do
criteria
like
for employability?
I think yes. Look, I won't say it's a criteria. Don't get me wrong. I won't say it's a criteria, but it's an added advantage. But you must not learn how to code, but you can if it's beneficial. I don't know if the English makes sense. It's beneficial to learn how to code, but it's not something that you must learn how to code, but you must learn how to write scripts. That's the one that you must learn how to do. You must learn how to write
Okay.
script. The reason why
Scripting.
people people ensure that you should learn how to code is because, for example, you want to write a Terraform code. Terraform libraries are already there for you. You will just pick the one that you want to use and run it. But there are some high-level engineering environments where the library you want to work on the library you want to use does not exist. So you have to build your own libraries and you have to write the code to build that library. You understand?
Yes, sir.
So if you tell them you don't know how to code, it's a disadvantage because if the library does not exist in public, no, if you want to deploy an application, if you want to write a Terraform code now, you just go and pick a library that gets the job done, and then you just implement it in your code. But there are some
No?
scenarios where the library does
I
not
don't
exist,
know.
so you have to write the library from scratch. That's where the coding skills come in, basically. You understand? So as I said, it's not a compulsory, but it's beneficial. It's something that you should, especially Python. If you know Python very well, you must not know Python to a good extent. But if you know Python, like comfortable with Python, you can scale through. That's why we also learn Python scripting. So for you to get you heated up a bit to the concept of Python, then you can build upon it. Someone
Okay, sir.
asked in the comments. Okay, continue.
Is Python scripting part of the curriculum?
Yes, it is.
Okay. So that can get
Yes,
us to.
you will learn the underlying concept of Python and then use that and build. Because you right now, what somebody asked, what is coding and scripting? Coding is used to build applications. Like you write code, with different components and everything. But scripting is automating manual processes. For example, I want to start my computer and in 5 minutes turn off my computer, or rather start my computer, press the start button, and then turn off the computer in 5 minutes. That's a manual process. Yes, shell is one of the scripts. Shell is a script. Writing shell is part of writing script, but shell scripting is shell scripting. There is Python scripting, there's shell scripting. You get, so there's even Golang scripting, but those are advanced ones. So shell scripting is just a scripting concept. You get, but I'll answer that. So I want to start my computer 5 minutes off my computer. I can write a script that can tell you by 2 o'clock, start the computer, press the start button, do all the A, B, and C, and turn off my computer. All these things should happen within 20 minutes. And when it's 2 o'clock, the script runs and executes all these tasks and turns off my computer without me touching my computer. That is what scripting does, basically. That's what scripting does, basically, for you. You understand? So scripting helps to automate
Yes,
manual
sir.
processes because you can be in an environment where you do 1,000 tasks. You cannot tell me that you want to do 1,000 tasks manually, one by one by one. No, you have to write scripts to automate everything. You can probably put it, set this script to run by 5 p.m. and it will run and everything will be executed. That's what scripting is. That's the concept of scripting because you must write scripts. For example, now you work in an environment, they can give you 1,000 names of employees to input into the server, create username and password for them. You tell me that you want to manually set username and password for 1,000 people. No, you cannot do it. So that's why you write scripts that for each user, create so username, create password. You run it and you go through all the users and set username and password at once. That is what scripting is about, basically. So have I answered the question of that guy?
Okay, is Is basically an
Yes, that's
automation
what the
process.
whole thing is automation. That's what the concept of DevOps now.
Okay. Okay.
Yeah,
Thank you, sir.
well understood. Very good. I'm glad. So this last question, Nkere Awaji, good evening.
Good evening, sir. Can you hear me, sir?
Yeah, I can hear you.
Okay. Thank you for your time and patience. I just wanted to find out. I heard when you were calling the tools, I didn't hear you mention Terraform. Are we doing Terraform in this training?
We will, but in the most basic way, because like I said, it's the foundation now. So you have to learn the cloud concepts first before we go into Terraform. You can't be automating what you cannot manually implement. So Terraform will be under the cloud section, but it's not as if it's going to be a section on its own. You get.
Okay.
It will be under when we learn cloud. But
Okay,
you have to
so-
learn cloud.
Okay. For the scripting, are we doing only Python scripting or we are doing
No, we're
Bash?
doing Bash. We're doing Bash and Python. So Bash will mostly Bash, then we'll not talk of Python. Because Bash scripting is the most popular one. That's where you have shell. Yes, the person that mentioned shell scripting. You
So
use Bash.
finally, why are we not doing Kubernetes?
We're not doing Kubernetes because that's the instruction from above. I don't know how I'm going to explain it to you because the last class we did Kubernetes, but we now found out that people did not know underlying concepts, but they're now going to learn Kubernetes. Because tell me why you are deploying Kubernetes environment, but you don't know Git. You cannot deploy using basic source code management with Git. So you're like, okay, we should not focus on the hot the high level ones and then focus on the so when you will now like want to do an advanced, probably we're not doing DevOps intermediate if we consider it, that's when we really go deep into all those Terraform and Kubernetes.
Okay, thank you, sir.
Yeah, that's just it. I knew I knew this question will come up. That's why, but I'm glad I was able to tackle it. Our last DevOps class we did Kubernetes and it was a pain because people were doing Kubernetes but they don't know Ansible. Tell me why you will not know how to do simple Ansible scripts, but you're talking about Kubernetes. It doesn't make sense. When the foundation is shaking, the building will collapse, basically. You get. So yeah, any more questions? Does anyone have any more questions? All right, so that being said, thank you very much for today. Hope you're geared up for a bumpy ride for the next 12 weeks. I didn't make the mistake again. For the next 12 weeks. Yeah, so next week we're going to talk about Git. And we're going to, like I said, we're going to go deep dive into the whole concept of version control and everything so that you understand when I'm talking about Git. And we'll do some, screen sharing and I'll show you the whole concept. So yeah, thank you very much. Thank you very much. Thank you very much. Yeah, I really enjoyed having the class as well. So that being said, yeah, take care. We'll see you on Tuesday. Thank you.